Linux kernel and how we will use the Linux kernel by communicating with the operating system process. Okay, so basically Linux kernel is an interface between it's a middleware between the hardware and the software. Means it can communicate with the hardware system calls by means of system call interface, as you can see in the diagram, and it can also communicate with the third party softwares or third party libraries, software libraries. So let's see here. In the hardware part, we have CPU, system RAM, devices. Okay, and in the PCI bus slot where we have seen we can connect our network adapters, graphics card, display controllers, and GPU. Okay, so how the Linux kernel works with them? It communicates with them by operating system calls. Okay, which we call as kernel. Means by use of the system calls, it communicates with the RAM and the display controller. Okay, so there is a process scheduler who would be aligning the process for communication between the RAM, GPU, and also the display controller. S- Same way that there would be memory manager who would be responsible for communicating the entire process with the memory management. Now, how other Linux kernel systems work? They work through SCI, which is called System Call Interface. As we can see that we have a 3D games which is operating. They are in Linux platform. Okay, so they would communicate with the Linux kernel by their SDK libraries. Okay, suppose we have a game engine. So the game engine they have a DirectX card or DirectX control card, which would be we can say an Iris graphics card also, which is inbuilt in our system, which or some laptops it comes inbuilt in our system for gaming platform. So in that way, or we can externally purchase graphics card for playing the games. So that graphics card they have a DirectX controls who would communicate with the subroutines in Windows library. As you know that there are different library DLL files in our Windows system 32. Okay, so these driver files they are game drivers are also there. So these are certain DLL system files that would help us to communicate with the GNU's library, or you can say in our subroutines through a system call interface. So this Linux kernel then establishes communication with the game engine driver, and in that way, our system works. Same is with 3D controls. They have also the DRM library to communicate with the subroutines. Now we will see in detail how this Linux kernel actually works in the Linux operating system, which we have our Ubuntu operating system. So we will quickly go through our lab. Here is our Ubuntu operating system. Now here we will learn about the locations of kernel information, the process information, the library files, log files, and their packages. Okay. Now, this is we will perform the following task like how this file system would be used by the Linux kernel. PS command will help us to, view the process information. We'll type the process information. So he'll get PID, time, and like the same we will see in task manager when we see the number of process in our Windows platform. Okay, so here you can see the number of process with their status, their process ID, the CPU consumption, and with their process ID. So in the same way that will be in the Linux command line interface, you will see. Now here we will check about the prop directory. Okay. So the programs such as PS and top would read the information about running processes from these directories. As you can see that we have the type the command here as PS, so it will show the running processes from the directories. Okay. So same way, if we will go to this directory PS and prop, then we will need to find out CPU info information. Okay, so we will communicate with the that information. So PS we will type here PSP it has gone. So the command not identified. So we have to very careful here with the command line interface in Linux because one command goes wrong, then the entire system will break, or it will not give the desired output. Suppose we don't know what command to use for this, so we will also have a hyphen with a help file. So it will give us more parameter, like how we can associate this command with all the information. Suppose I want to list the command line unsupported option for BSD. Okay, no issue. So we will see the pseudo files for the, let's say this is the directory. So there are pseudo files that can be used to alter the settings of running kernel. Okay, so likewise we have in our Windows, I has have told you, there are the DLL files are there. Okay, in the system32 folder. Okay, so these are the configuration. Wait, let me show you. Okay, so we have checked the driver files here, the dots with .sys extension. Okay, there are also certain, these are the all system files for our drivers. Now, in the same way, in Linux, we have also the file extension with this in the sys directory we have to use, and also we have the kernel is also using the configuration file with the conf. Okay, likewise we have in Windows. So this file that can be used by Linux kernel to change the make the changes to these proc files where our system is starting. Okay, so let us go through the command list. We'll go through the step one, where we will find it that what are the files containing in our proc directory. Okay, so we will type this command ls proc. Okay, so see, we will toggle the full screen to have the desired output. So it would be better to see. So see here, ls in the CPU information we have Kali systems, call systems, then mount folders we have. Okay, so these are the list of devices we have, and devices information with the system sys files. Okay, so likewise, I will go to my to guide, and with the sudo password also the root privileges we can enter into root credentials. So if I have to enter, see this is a sysadmin user which is in Linux, but we have to migrate to, or we can to switch to root directory. So I will type it su. Okay, now it will ask for the password. Okay, so here for our lab environment, we will use the password as netlab123, and I have pressed enter. Okay, so now you can see that I have entered into the root directory. Okay, means which is the root privilege account for Linux, which is the default account for Linux. Now from here, if I have to maintain the system changes, or if I have to get to know what all information are there for the, as we have checked with the sysadmin account. Okay, the same way we can do it with the root user account also. So let's see ls TROC. Okay, so here you can find it that all the file systems information, and as well as the disk statistics. Okay, so let's move further. Okay, there is also an echo command to execute, which causes a command to enter into a line. Okay, so we will see further commands. Now here we have the cat command, then pa to view the information about the files in this directory, or the process running in this directory. So we will clear the screen, clear, and we will type the command again for this one, cat command, and in the proc directory proc, then hyphen l, or no, process ID 1 we have to do. So I will type 1. Then by this in command line, I have to show the output, and echo will print the statement. Okay. So it will view the information about the this process identifier of 1. Now I have to list what all information is there. So with I will type this. So in this directory, these are the running processes or systems. You can view in the full screen to have better visibility. See, so in this directory, we have the process with the ID 1. Okay, and this will display the information in our Linux operating system, which is Ubuntu. Okay, so echo command is executed immediately after the cat command since it has no argument. Okay, it functions only to put the next command on a new line. Great. So in that way, we have executed this command with no argument. Echo command has not given any argument, so it will execute those command without any argument and put the our execution in a new line. So same way we have discussed ps-p1 command so that we would list the output of the process ID directories. Now let's see the step 3 what they are saying. Now, in that case, we will see what arguments will be passed at boot time. So, in this command line, if we have C, we can see the output contains all the information, such as the command line, the parameters, the special instructions that were passed to the kernel. Okay, so in the same way, we can write this command and we move further. Now, how we can manage the process or stop or start or stop the running process in our systems, like we do in Windows by Task Manager. Let's say I have to do it by I have to kill any process. So this is the process, and suppose I have to kill any kind of a process here. These are the multiple process, so I can right click on it and I can end the task. Okay. So likewise, how the execution of managing the process runs in Linux. Let's see. Okay, from the terminal, we'll type the following command. Let's go ahead. So ping command will type and localhost. Localhost means our local operating system, which on which we are working. Now in this dev directory is there, then man. So let's see what the output comes. Okay, now remember that we are on the root privileges account, so it will may take some time to gather the permissions or the required privileges to run this command. That's why it's taking time. Here also they have mentioned that the terminal may appears to hang up at the this command. The system will continue to ping until the process is terminated or suspended by the user. Okay, so this will be running the process. Now we can terminate the foreground process because it's taking so long. So I will press Control C. Okay, great. The process gets terminated. Now we will see again the next part, what they are trying to say. So if we will run this part with the ampersand, okay, ampersand, the processes would be started in the background, allowing the user to maintain the control of the terminal. Okay, so this is the purpose of using ampersand. So it would allow the user to maintain control of the terminal. Same way, if we want to get the process ID 107, then we can enclose in a bracket and we can get the system-wide process of that. So process ID will be likely different. So this will reduce the time to gather the information on the process ID. So next part we will check on this. Let's see ping localhost greater than symbol. Okay, null 6. The terminal is hanging and ampersand. So let's see what happens. Okay. So it's giving the process number 86. Okay. So there are, depending upon the running processes, it's giving the output. Okay. So likewise, we can get the information of the creation of process. Now we'll move with the jobs. What are the jobs running in the system? So we will directly type it as jobs command. So it will be running what job is currently running in the system. We have run this command before. Now the output we have got. Now start with another command with this terminal. Okay, it will also give the same thing. Jobs, same. Now let's see the verify that two ping commands are running. Now bring the first command to the foreground. by typing this one. Okay. So what we'll do, fg command will type and percentage I. So no such job. No, because I have typed in L, no, because it would be showing the number of process. So if I type one, then it will show which background command which you have run before. So it will clearly shows the output. Now next we will use the Control Z command to stop or suspend the process. So let's press Control Z from my keyboard. Okay, so this process gets stopped. Now we are good to go with our next command. Now, if you have to check the background, stop executing the command in the background, then I will do bg command with the percentage of means background process of 1. So I have stopped this background process. Great. Next, we'll see the number of jobs which are running. Okay, this is the jobs running in the background, which is the output. Now next, same thing we will have the output with it in, so it will give the process ID, and in the same way the jobs running jobs will show. Okay, now suppose I have to kill the jobs with the percentage 3. Let's see, no jobs such job, because there are no such job with the 3. Suppose I will press 1. Okay, so it has executed successfully because the number one job has been uh, terminated. Now let's see, since the jobs will see the numbers 1. Okay, so this has been terminated with the job identifier. So you can see it in full screen as well. See, these jobs we have killed the process. Next thing we will go ahead. How kill all command will works with the ping command. Okay, so after executing the king kill all command, wait a few minutes and run the jobs command to verify that all the processes have been stopped. Now, the another thing we have to define is decide is like once all the ping commands which we have run, okay, are they successfully killing it or not? So how to check that? Let's clear the screen and I will check the status by kill all command and ping. Okay, so no process found. Let's say the jobs. If are there any jobs, no jobs are there. Okay, so this output would be because there are no jobs. We have already terminated the one existing job previously, so there are no jobs left. Okay, so that is all about the ping and jobs utility in the how the data is stored in the kernel. Next video will discuss again the further part how to use stop command to view the process. Thank you.